Hello, I'm Leonardo Ferrer, and this is my 212 graphic submission. So first off, I'm going to start talking about all the textures in the scene and how those are created. Begin by creating our VAOs and our buffers. Once we've created the VAOs and our buffers, we then need to assign them. So to assign the VAO, we do GL bind vertex array, and then to assign the buffer, we do GL bind buffer. And then after that, we want to make sure that we're passing in the data for the buffer. So for example, for the field, we would pass in the field vertices, and then we do a draw call. After this, we want to make sure that we are assigning the vertex attrib pointer. So we pass in the location, the type of vector that we're passing in, and then we pass in the vertices. The texturing stage, you want to specify the active texture. You then want to bind the active texture, and then after this you have to set parameters. So for example, you see the field, you can see that it's a repeating pattern. That's because I've set it to repeat. And then you need to generate the MIP maps, and then you have to use the assignment you made earlier, for example the grass texture location. You then use the command to get the uniform location. You pass in the program ID and the name, and then you call uniform I, and then you specify the number. So next we have to talk about the shaders. So for this we have to talk about what a shader is. A shader is a small program that is used in the GPU, and it's written in the OpenGL shading language, GLSL. With shading there's two main stages, which is the pre-vertex processing and the pre-fragment processing stage. So we begin with the fragment shader, and then here in the layout you have to specify where your coordinates go and where your texture's coordinates go, and then you have to then assign the coordinates to the object that you're specifying. So for example, if we're talking about the field, we would do something like this. If the object equals field, then the coordinates are equal to the field coordinates, and the texture export is equal to the field texture coordinates. In our fragment shader, we would specify a struct with the light and materials. However, I'll talk more about this when I talk about the lighting. In our fragment shader, we take in information from the vertex shader. The information we want to take in are the texture coordinates, and also for the spheres we want to take in the information about the normals. In our fragment shader we also would specify the structures for lights and materials. However, I'll be talking about that later on. And then we assign uniform samplers to the textures. And then what we want to display out is a vec4 containing information about the textures. So here we quite simply use this command. For example, for the field it would be field text color, texture, grass texture, and then the texture coordinates export. I'll now be talking about how the balls are movable and the player angles are movable, and the player has a choice between backhand and forehand. So the player has an opportunity in the beginning to move the jack up and down to decide what position, and then they can throw the jack. The ball is also throwable, and here's the other way. That was backhand and forehand. So I'm going to talk a little bit more about how this was done. As you can see, when this ball is thrown, it has a heading which it faces in and then travels. The way this was done in modern OpenGL was actually to do a conversion between spherical coordinates to Cartesian coordinates. So in the screen we can see this equation above. So to assign a direction, we needed to figure out the cosine of the vertical times the sine of the horizontal, and then we needed to take in the sine of the vertical, and then finally take in the cosine of the vertical times the horizontal, and then this gives us our direction. And then we need to specify what position is to the right, and you can see here we done the sine of the horizontal take away take away pi divided by 2, and then we took in 0, and then the cosine of the horizontal take away pi divided by 2. And then we can do GLM cross product to get the cross product of the right and the direction we're facing in to then get the up angle. This allows us to move in the scene, change our directions. The sphere is created with the following function. So as you can see here, we are accessing the sphere's coordinates, which are passed in. These are vec4s, and then we take in the texture coordinates via the vec2s, which give us information about the tiling. As you can see, we go through each of the stacks and we assign v and phi. We then go through all of the slices as well, and then we set the u value, we set the theta value, and we set x, y, z. On top of this, the sphere vertices take in not only coordinates and the text coordinates, but they also take in values for normals, because this is used later on for calculating the texture of the ball. When we encounter an object that's a sphere, we want to set our normal to be the normalized sphere normals that we've exported from the vertex shader. We then want to assign the light direction by normalizing the vec3 of the light coordinates. We then want to use this equation to work out the diffuse lighting. We then work out the halfway by taking the light direction plus the eye direction, and then through a ternary operator we work out what value we want to assign it to. Then we work out our specular lighting by taking the normal, the halfway, the shininess, and then we want to times that by the light colors and the specular reflection. And then what we actually output is a combination of all these things together, the ambient, the diffuse, and the specular. So then that's actually passed to the texture. In the scene you can see the scenery is the trees. The trees here are of almost exactly the same value. They have the same vertices, they're just in different locations. So these actually share the same texture coordinates, which actually improves the efficiency. You can see the boundaries for the ditch also share the same texture of the field. However, they are actually changed by changing their ambient by timesing it by a vec4. So this saves on resources and it enables to give the outline of a field as well.